Welcome to episode 15 of our workshop. So we're almost at the end. So we will implement DB. There's actually one other pseudo op I want to implement, and that's EQU. And that's going to allow us to define constants, which we can then later on reference in our programs. This one's pretty straightforward as well, so let's just get this one done real quick. EQU says I have a label and I'm going to tell you what its value is. I'm not going to rely on where we happen to be in the program. I'm going to tell you this is the value I want for this label. So the first thing we got to check is if we have an EQU instruction, then we must have a label because it operates on labels. So if we don't for some reason, we need to error out. Must have a label in EQU statement. Let's think about this. So what do we need to do? We need to say that if we have a digit or a dollar sign, and I think you know what's coming next, then value is going to equal. Right, this should not be a surprise to us at this point. We've kind of used this idiom over and over and over again to convert a number either into decimal or into hex, depending on if there's a dollar sign at the beginning of it or not. Otherwise, we should error out. Okay, else, throw new exception, EQ statements must assign a number. There we go. Let's carry on. So after we've done this now, oops, spelled exception wrong. All right, so if we're in our first pass, then what do we need to do? For in our first pass, we need to actually create a new symbol that has the name that we asked for and has the actual value that we asked for. And so the way that I'm going to do that is say autotemp equals output.address, one too many equal signs. Then I'm going to say output.address equals value. I'm going to say add symbol tokens output. I'm going to say output address equals temp. All right, that's just an easy way to make sure that we don't forget where we actually are in the address, but store the new symbol with the information that we want. And that's it for EQU. So the only thing we have left to do now is DB. And so DB, well, so let's say the easy way out for DB first. So the easy way out for DB would be same thing. Takes one argument. And we'll say first one can't be empty, and the second one must be empty. And it can take a number or a hex digit, right? But just one byte. So this is going to look familiar to all of us. So if it's a digit or it's a dollar sign, oops, forgot a parenthesis there. Yep. So value will be tokens first. And if the first digit is a dollar sign, first character is a dollar sign, then we just want to chop off that dollar sign and make it a decimal, or it will be right hexadecimal or decimal, depending on whether or not we have that dollar sign. Now what comes next is, fairly interesting. If we're in pass 2 and all we care about with DB is making them, a single 8-bit number, then we can just say, write out that number. But I'm not so sure that that's necessarily exactly what we want. It is definitely what we want if we have a number. But what if, like is done in the traditional CPM assembler, we want to be able to write strings. DB is how we will write strings. So DB can be used to simply give us an 8-bit number or an 8-bit hex digit and stick that into your code, into your executable. But it's also going to be how we are going to deal with strings. In the CPM assembler, they actually let you have multiple items in a DB call. We're not going to do that. We're going to take the lazy way out and just say one argument per DB instruction. But we do need to deal with strings. So let's do that. Let's actually deal with strings. So we're going to deal with the logic first, and then we'll go back to our parser and actually parse out strings. So it's going to be the same deal here. If we are in our first pass, then we should be able to say if we have a label for some reason, we should add that label. And actually, it might make more sense to always do that. So let's take it out of here. Actually, let's put it up. Let's put it up here. Right, because no matter what, it may always be the case that a DB has a label attached to it. So we just always want to make sure that we can correctly assign that label. If we have a string, if we're in pass 1, then we probably shouldn't do anything. But if we're in pass 2, there is something that we are going to need to do, and that's going to be to actually output the values of the string, right? Each individual character of the string. And now that I think about it, there might actually be something important for us to do in pass 1. And that will be we need to account for the length of our string in our address calculations. So we actually need to increment output address by the length of our string, because each one of those bytes in our string will go into our final executable. So we do need to track that. We do need to account for that. Then in pass 2, we can say for each, and I'm going to say for each character in our string, just output that character. And it'll be a U byte, right? Because it's an array of U bytes. And that's really it in terms of what we need to do to output a string. If it's the first pass, we need to count the number of items in the string and account for that and adjust our address for that. If it's pass 2, then we just need to print out each one at a time. But it does mean that we are going to have to update our parser a little bit. The good news is that we don't have to worry too much about things. Right? So the only time we can ever have a string is when it's the first and only argument to a DB instruction. So the only part of our parser we're going to need to worry about modifying is the part where we get the first argument. There'll never be a string in the second argument. There'll never be a string in a label. There'll never be a string in an instruction. There will only ever be a string in our first argument. And there are a couple of ways we can do strings, right? We can do a C-style string in quotes, or what I'm going to prefer to do is a Pascal style string with single quotes. Just because I'm not going to bother with the like backslash new lines, backslash nulls, right? You can just make a second DB for that one character and then move on. So I think Pascal style strings will make things a little bit easier for us to wrap our heads around. So what we're going to need to do is we're going to start off by saying if the first character of our argument is a single tick, and I'll just push all these up since these are now going to be in an else block. So if the first character of our argument is a single quote, and therefore what we have here is a string, the first thing we should do is skip past that first character because we don't want to process that first character. That first single quote is not actually part of our output. It's just delimiting the string itself. But then the logic is pretty straightforward. It's not so different than what we are used to. We're going to iterate over the string. Right, make sure that we don't go past the length of a line because we don't want that. We're going to say if the character we're currently looking at is also a single quote character, then there's two things that can happen. So if we see a single quote character, it is either literally a single quote or it is the end of our string. The only way we're going to know that is by checking to see if the next character is also a single quote. So if we're not at the end of the line, right? If we are at the end of the line, then it must be a single quote. So if we're not at the end of the line and the next character in the line is also a single quote, then we're going to say, let's add a single quote character. Let's increment I, and let's continue on. Otherwise, we're going to break, because that's going to be the end of our string. All right, so what we're doing here effectively is saying, if we have a single quote that is immediately preceded by another single quote, what you're actually asking for is a literal single quote. So we're going to append the single quote to our argument, and we'll continue on. If we find a single quote all by itself, it's the end of the string, and therefore we're done. If we don't have a single quote, in every other case where we do not have a single quote, we will simply append the character to the first string. And so what we're really doing here is we are incrementing our string, but we're also building the string one character at a time. So we're not doing the thing we're doing in every other instance where we're just taking a slice of the line and calling that our first string. We're actually going to go ahead and literally build the string if it is in fact, something delimited inside of single quotes. It's not going to change the count, all right? We are accounting for the number of items we are iterating over. So it's not going to ruin the count for us in terms of where we are, in terms of the actual line of code. But I found it easier just to build the string from whole cloth rather than trying to do a slice because of this. What do you do if you have two single quotes right next to each other? But that's it. That's the only thing we need to add in order to deal with strings. And so with that, I am going to save our work. And something that's kind of incredible is we are actually at the point where we have finished our assembler. And so if you did all of the homework and you worked through everything, you should have now a working assembler. I'm going to copy in one that I had pre-done because I did not do all the homework. I'm going to run make real fast, and that will build our assembler. And I'm just going to use GDC to build our assembler. And once that's done, I should be able to now run my assembler on that original Hello World source code that we saw all the way back at the very beginning of the workshop. And if I do that, sure enough, I now see a hello.com file. And if we run the hello.com file, we in fact see, finally, Hello DConf Online 22. So I want to thank you for coming with me on this adventure to build an assembler. One of the things that I mentioned in my talk that was shown before this workshop was, I've always been fascinated by programs that can build other programs. I love the idea of that kind of meta work of how do you solve the problem of writing software. And I think a lot of us enjoy those questions, right? We are here hanging out in the D community after all. And for those of you who are new, welcome to the D community. Hopefully this also kind of showed you some interesting facets of the D language, particularly if you are new to D and you are just kind of trying to look around and see what things are available to you. And if you're more on the new side of coding itself, spend some time, review some of these episodes if you need. If you can walk through all the different episodes and you can talk to somebody about what it is that your assembler that you wrote is doing, then you have a pretty good understanding of how to take source code and turn it into instructions that an actual computer can actually understand and process and do something with. And I think that's really awesome. I think people tend to think that compilers and assemblers are these kind of magic things that require so much theory and knowledge to understand. And it's just not true. It just takes some creative thinking about the problems that we need to solve, and sometimes just simple, potentially less inefficient and less elegant solutions to solve those problems. And we too can have an actual working assembler, compiler, what have you. So with all of that, I'd like to thank you one last time for coming through this adventure with me. I'd like to thank you for attending DConf Online if you were attending DConf Online. If not, come check us out. You can check us out at dlang.org. There's a nice forum in there. If you want to check me out, you can check me out on my own homepage. And with that, I will say goodbye one last time and enjoy the rest of your day.